Hey everyone, welcome to this video. My name is Alex and today I want to show you how you can make your own NFT on the Cardano blockchain. In this video I want to walk you through each step necessary to mint your own NFT while you'll have full control over all the properties those NFT has, and it's basically for free, excluding the transaction fee. This will be exactly the same way as I've described in the guide I did for the Cardano Foundation Developer Portal. So if you want to follow along, I've left a link in the description. Make sure to click it to have some sort of script and to have all the commands copy and pasteable ready by your hand if you want to make your own NFT while watching this video. Before we start, please keep in mind that it's quite technical. You will need some sort of basic understanding of how a Linux operating system works and also on how to navigate on a Linux operating system, how to move around, and basically how to, you need to know your way around the terminal or the bash. If you just want to make a single NFT and then forget about it, I highly recommend checking out one of the many self-service portals out there like the great nftmaker.io, where you can just simply upload an image and it will be minted into an NFT for a small fee. This tutorial, however, will teach you everything which is under the hood of all of those self-service portals and will hopefully leave you in a situation where you can mint 1 to 1 million of your own custom tokens or NFTs. So with that out of the way, let's get started and start minting our NFTs. So before we start, we make a new directory called NFT and we change into it. This is just to have a better overview and just a clean working directory. Before we start, we need to make sure that we have a fully synced and running Cardano node in the background. If you're not sure on how to install a Cardano node, there are many tutorials out there. I will link a few tutorials in the description, so make sure to check them out if you haven't set up your Cardano node. I already have my Cardano node up and running, and in order to interact and communicate with it, we need to export a variable called Cardano node socket path, which will hold the path to our socket file. If you're not sure where your socket file is located, please check how you start your node, because in the startup parameters of the node you will see your path to your socket file. In my case, my socket file is located at opt Cardano cnode sockets node0.socket. Next up is checking if our node is up to sync, and for that we will just query the tip of the blockchain with the command Cardano CLI query tip -- mainnet, and we will compare this slot number to the slot number of the publicly available Cardano Explorer. If they match, we know we are pretty much in sync and up to date and our transactions will actually succeed. Another important information is which version I'm using. I'm currently using the version 1.27.0. The version will most definitely change in the future, so please keep that in mind that maybe some commands need some tweaking. All of the commands I will be showing you now work for version 1.27.0. Because we will be building a transaction from scratch, and a transaction command from scratch is quite hard to read, I will set almost all of the important informations and write them into a variable. So first up is our token name. Next up is the token amount, which we'll set to 1. We will also create a fee and an output variable, but they will be set to 0 for now, and they will be set later on as they will get calculated if we have our first transaction ready. We also need the IPFS hash of our image, which we will be tokenizing. So if you're unaware of how tokens in Cardano work, please make sure to read up on how the metadata attachment and everything else, how the architecture works. So I will be using the image I've just recently uploaded to my Pinata Cloud account, which is called Just Married, and we will just copy the IPFS CID hash and set it as the IPFS variable. Okay, so now we have set up everything, so we're good to go. First thing we're going to do is generate some files we need to make a transaction. And the first files we need are payment keys. You can generate the payment keys with the command Cardano CLI address keygen -- verification key file payment.vkey and signing key file payment.ascii. And after issuing this command, we now have two new files called payment.ascii and payment.vkey, standing for signing and verification key, which we will need later in the transaction. We now use the verification key to generate a payment address in order to send and receive transactions. The command here is again Cardano CLI address build -- payment verification key file payment.vkey, the key we just created, and the output file is called payment.address. So as you can see, we now have three files. We have the keys and an additional address. Since we now have an address to receive and send funds, we will also set a variable for this address and just output the contents of the payment address into the variable called address. So we can now check this address and see the balance of it and check the unspent transaction outputs. For that, we just issue the command Cardano CLI query UTXO -- address, and we will reference our address variable instead of the payment.address file. And as you can see, we have no unspent transaction outputs and no funds available in our address as of now. So that's why I'm going to fund this address real quick. I'm going to send, I don't know, about 5 ADA to this address. So we will have enough ADA to issue a transaction and mint an NFT. And there we go. We now have 5 ADA available on our address. Because we need to calculate the fee for the transaction we are going to build, we also need some parameters which we will be exporting into a file called protocol.json, and we issue the command Cardano CLI query protocol parameters and save it in the file protocol.json. So just a quick recap, we now have 4 files. We have our 2 keys, we have our payment address, and we also have a file, a JSON file, which holds all the protocol parameters. In order to make tokens, we also need to specify a policy. We will do that in a separate folder and just make a new folder called policy. So for the policy, we will need 2 additional keys, which we will generate with this command. Again, there will be a verification key and a signing key, and both of them will be generated in the policy folder we just created. Please note, we are not changing into the policy folder. We will stay in our NFT folder. So the commands we are issuing are done with relative path. Here's a quick overview of our folder structure. We now have an additional folder inside our NFT directory, which holds 2 policy keys, apart from what we already have, which is the payment address, our 2 payment keys, and also the protocol parameters. In order to mint native assets, you need to have a so-called policy script, which defines special characteristics of the native asset as to how it behaves. One such characteristic will be like how long can the asset be minted, as well as which signatures will be able to sign the transaction to actually mint the NFT. If that's too technical, don't worry, there is a whole GitHub documentation page I will put in the description called MULTISIGNATURES. In order to speed things a bit up, I've generated a couple of commands you can find in the guide on the Cardano Foundation Developer Portal. Just copy and paste them into the terminal and the policy script will be automatically generated. So this is what the commands look like. They will automatically generate a policy script file, which we can now find in the policy folder over here. And the policy script file now looks like this. As you can see, we have 2 properties defined in the script files. If we look at the property with the type before, you will see the value of the slot number. This value represents the latest slot number in which the transaction can succeed. So you need to make sure that you submit your transaction before the slot number we now put in is reached. Don't worry, we have plenty of time. If you used my commands, it will query the current slot number and add 10,000 to it. The rule of thumb is there's a slot every second, so if you add 10,000 to it, you roughly have about 10,000 seconds in order to successfully submit your transaction. So keep that in mind if you're working for someone else or if you're making tokens for someone else, to set a slot number accordingly, to have enough time to send the token, verify it, and maybe even burn it if your customer is unhappy with it. The second property, which is called SIG, holds the value of a key hash, which basically defines which keys are allowed to sign minting or burning transactions and making or destroying tokens. So those are the two properties we defined. You can obviously set more properties. Again, please read up on multi-signature scripts on what you can define and how the architecture looks. The slot number we've just set in the script will be needed in the transaction as well. That's why we will set a new variable called slot number with the corresponding value of the slot. And we will also make a new variable which will hold the path to the script, to the policy script file. Last but not least, we also need to generate a so-called policy ID, which will be the unique identifier for your asset. We can generate a policy ID and save it in a file with the command Cardano CLI transaction policy ID -- script file, and we will throw the output in a file called policy ID in our policy folder. Next up, we also need a file to make our native asset truly an NFT. So this file is needed to later on display all of the attributes and the image from the NFT. And again, I've also provided some commands to automatically generate that file based on what you've set your variables to. So as you can see, we will not only reference our policy ID, we will also reference variables like our token name. So if you just copied and pasted the commands from the Cardano Foundation Developer Portal guide, the metadata attributes will be very minimal, like the bare minimal to be an NFT and in order to display a picture. So the NFT I want to make is going to be a wedding present. That's why I will be adjusting the metadata accordingly, setting the description and the name to something more appropriate. Next up, before we are going to build our actual minting transaction, I will once again query the address, and I'm going to save all of the needed values in a variable. The first variable we are going to set is called tx hash, and we will just input the tx hash value. The second value we are going to need for our transactions are the txix, which we will set to 0 as they are 0, and the amount will be set to 5 million. Please keep in mind the unit here is loveless, so 1 million loveless is 1 ADA. I've sent 5 ADA to this address, that's why we have 5 million loveless. We will also set a policy ID variable, which will be set up with the output of our policy ID file. And we are ready to build our transaction. So a quick word about a transaction process or building a transaction in Cardano. So in order to successfully submit a transaction, it's actually a 3-step process. The first step is building a raw transaction without any fees attached or nothing. This will be saved into a file which has a certain size. Next up, we will calculate the fees based on the first file, and we will resave or overwrite the file with the correct fees, and then we will sign this file, and then it can be submitted. So those are the necessary steps. So we will issue a transaction command and save everything in a file called natx.raw. The transaction command has a couple of inputs and outputs, which I won't go into too much detail. If you want to read up on how to build a transaction, I can highly recommend the Cardano Developer Portal, as I've already said. and there are some few other tutorials floating around if you want to read up on how transactions work in Cardano. We are now going to calculate the fee based on the size of this file, and we need to set our output accordingly because we will be sending 5 ADA in, subtract the fee from the ADA, and the leftovers will be sent back to us with the token. So we need to calculate the fee and we need to calculate the leftovers. The fee can be calculated with the command transaction calculate min fee, and we will base it on the matx.raw file. We will also specify how many inputs and outputs we have, how many witnesses or signing keys we have, and we will also reference our protocol parameters. In order to just get the value of the fee, I will pipe it into the cut command, which will cut everything away and just leave the fee. So the fee for our transaction will be 168,401 Loveless. As I've said, we also need to calculate our outputs or our leftovers. So our 5 ADA will be the input of the transactions. We will subtract the fees, and everything that is left over is the output, which needs to be also addressed in the transaction. Since we are going to send it back to us, there's nothing to worry about. So now we have our correct fee and we have our output values set. We are now able to rebuild our transaction and basically override our matx.raw file with the correct values of a fee and of the output. In order to do that, we just reissue the transaction build command and override our matx.raw file. In order to successfully submit our transaction, we also need to sign it. Basically a way to prove we really are who we claim to be. So to sign a transaction, we just issue the sign command. We input our payment signing key and we input our policy signing key. We also input our raw transaction file, and the signed transactions gets saved in a new file, which we will be calling matx.signed. So here are the files we now have. Apart from our payment keys and address, we have a folder which holds our policy keys, and our ID and our script. We also have our protocol parameters. We have our metadata JSON file, and we now also have 2 matx files. One is the raw file and one is signed. And the last step is to submit the signed transaction. So we type in Cardano CLI transaction submit, and we just submit the matx.signed file. And if we are querying our address, we now have a bit less Loveless, but one additional NFT. In order to properly display your NFT, you just copy the asset ID, which is everything before the dot and your asset name. You just copy that, head over to pool.pm and search for your ID. And there we have it. Our just recently created NFT displayed on pool.pm. Everything works properly. We have our picture and we also have our description and our ID set properly. The name gets displayed, so everything is working as we've expected. With that being said, congratulations on your first NFT on the Cardano blockchain. There's just one little thing which I will not talk about in this video, which is on how to get your NFT out from your payment address to your RAW, your Daedalus wallet, or just to a more user-friendly wallet. Please check out my other guide on how to mint native assets. In there, there's the complete token lifecycle, and I also covered sending and burning tokens. So if you have any other questions, just leave a comment and I'll be sure to answer as much as I can. Also, I'd love to see your first NFTs which you've minted with this guide, with this tutorial. Please leave a comment and just paste the pool.pm URL to the comments so I can see all of your wonderful and gorgeous self-minted NFTs, and we can all share our NFTs and art and stuff we wanna keep forever on the blockchain. I hope you've enjoyed this video. I hope you learned something. I hope I did a good job of explaining everything. I'll be more than happy to try to answer everything and get you up and running to mint your own NFTs and help you where I can. Thank you so much for watching. Stay healthy, and I will see you on the next video. Bye.